Good morning. We're going to continue today with chapter 13, in particular section 13.2, and we are going to look at in particular two hyperbolas, which are graphs that have those two pieces like that. And I want to remind you that they're conic sections. So let's look at that picture of the book that I showed you last time, and imagine that you have a two-piece cone, and then you take a sheet of paper or a knife, and you cut the cone at a 90-degree angle with the axis right here, so that will give you a circle. If you actually cut it at an angle, you get an ellipse. If you cut it at an angle but you get off the cone, you get a parabola. And then when you cut it straight with a line that is parallel to the axis, like you see right here, you get a picture that is called a hyperbola, and it has two pieces. So that's what we're going to study in section 13.2. And we're going to first start by looking at the equation of a hyperbola, how to graph the hyperbolas using a rectangle method. And then we're going to look at all the conic sections together and looking at their equations. And last, we're going to look at square root functions, which may not look like any of the conic sections, but they come from the conic sections. So far we have actually looked at circles and ellipses, and one of the last ones that we looked at was ellipses, and you've seen that they have an equation similar to that. If you notice, the difference is that when you're looking at the hyperbola, it has a negative between, so it will matter, it will be different if you have an x square minus a y square or a y square minus x square. So what is the big difference? If you have an x square first, then it is the kind of hyperbola that opens to the right and to the left. So it will not cross the y-axis, so it has no y-intercepts, and then it will cross the x-axis at this point. And by the way, this point right here, it's that negative a and a positive a that you have in that first term. And the b will mean something with respect to the rectangle that we're going to look at, but it's not a point on the graph. Now, if you are looking at the hyperbola that has y squared first, then it will be the kind that opens up and down. And we have it on the next page, and it has no x-intercepts. It doesn't cross the x-axis at all. Now, coming back to the equation here, notice you have that b squared. So that b square will tell you what the points are on the y-axis. So that's a b, and this is a negative b. And the a will mean something, but not a point on the graph. We'll talk about that next. Now, this is just a quick matching exercise so that you get acquainted with the equation. Notice you have very similar equations. X squared over 4 minus y squared over 25 equals 1. And you have y squared over 25 minus x squared over 4. So you see the negative. That's one of the first things we're going to look at. And you know that it's going to be a hyperbola, and it has two pieces. Now, the next thing that you need to look at when you see this one is that you have x squared over 4 first. So immediately it should come to mind that this is the hyperbola that has two pieces, one that opens to the right and one opens to the left. So I can match it already with D, is the graph that opens to the right and to the left. So if it opens to the right and to the left, it will miss the y-axis completely. So it does not have y-intercepts. But it will have x-intercepts right here. And those x-intercepts come from that 4. And so it would be, that's actually a 2 square. So then it would have x-intercepts equals 2, 0, and negative 2, 0. Now, by process of elimination, you know that the remaining characteristics in column B will match with 2. But let's think about it, and let's think about what this is saying. Again, the first thing that I notice is that I have y squared over 25 first. So then automatically I think about this will be the kind of hyperbola that opens up and down. So if it so I know already it will be matched with F. Then if it crosses, if it opens up and down, then it will miss the x-axis. So then that means it has no x-intercepts, so it will be matched with A. But then it will have y-intercepts right here. And that 25 that is underneath the y square, that's what gives you what the y-intercepts are. And the y-intercepts always have 0 for x, so then I know that it will be matched with C. And then here in the conclusion, I'm just kind of summarizing the characteristics. A hyperbola that opens to the right and to the left and has x-intercepts of negative 2 and 2 and has no y-intercepts will actually be the x squared over 4 minus y squared over 25 equals 1. And it will not have y-intercepts. Now, we'll talk about this in a second. I just want to fill in the blank for the next one. The hyperbola that opens up and down, and it has y-intercepts of 0, negative 5, and 0, 5, and it has no x-intercepts. That's the one that was y squared over 25 minus x squared over 4 equals 1. Okay, so let me go back to this one here because I have a little bit more space here. I can extend that page if I need to. Now, the hyperbolas are going to have either x-intercepts or y-intercepts, but not both. And it all depends on which one starts out first and if it opens right or left. But I want you to see why this particular one will not have y-intercepts. When you're talking about y-intercepts, then the x value is 0. So look what happens if I substitute x for 0 here. And this is not something you're going to be required to do, but I want you to see why it doesn't work. So I substitute 0 here, so that means this term here will completely turn to 0. So I'm left with negative y squared over 25 equals 1. Say you multiply both sides by 25, so you have a negative y squared equals 25. Multiplied or divide both sides by a negative 1, and you have y squared equals negative 25. Now, when you tried to take the square root of both sides of that, it will give you y equals positive and negative square root of negative 25. And you get imaginary numbers, but imaginary numbers have no place in the xy plane when we're graphing. So that's the reason why that you don't have any x or any y-intercepts, is because it leads to imaginary numbers, and we are avoiding those anytime we graph. And something similar will happen with this right here. There's only, and we don't have to do it, and so I don't bother looking at that, but that's what's going to happen. And that is the reason why you would not have x-intercepts for that. Now, I gave you the graph and we kind of briefly look at what the graphs are, but in reality, what we want to do is we want to be able to graph from scratch. And if you remember from the ellipse in the previous section, you have the hyperbola. This particular one had a 4 and a 25. So you had a squared equals 4, and that gave you a equals positive and negative 2. And you had b squared equals 25, and that gives you b equals positive and negative 5. So we know that this is a hyperbola because of the negative, and we know, since it starts with the x squared over 4, that it opens to the right and to the left. But in order to figure out exactly where the graph is, where the points are, we need to use this kind of in the same way that we used to graph ellipses, so that we can do the boundaries for that. So let me go ahead and do the lines for the rectangle. So this will mean the plus or minus 2, since it's underneath the x squared, it will mean that you go 2 units to the right and 2 units to the left from the center. The b squared was underneath the y squared, so that means we go down 5 units and up 5 units. So let's go to the next page, and I'm going to make this bigger. Okay, so here is the center. And remember, we go 2 units to the right, 2 units to the left. So I would be right here and right here. And then I go 5 units up and 5 units down. And those may not be exactly where my points are, but I am going to go ahead and draw a rectangle. And let me see if it lets me use this, and it lets me change the color so I can do it in blue. Okay, so I would have a rectangle now that looks like this. So if I were graphing an ellipse on the previous page, let me adjust, see if it lets me adjust that, because I don't think it's right. So if I were graphing an ellipse from the previous section, it will fit right in that box. But the hyperbola is different. Now, we have another set of boundaries here that are the oblique asymptotes, and the graph stays between those lines. So what you do is you take the opposite vertices of the rectangle and the center, and you draw a line there. So let me try again this line. Let me try this one, but make it a little bit narrower. So now we're gonna, and I may have to adjust that line once I'm done. You get to erase, I get to use this handy tool where I adjust them. So that will be one asymptote for that particular hyperbola. Then let's do the same, but let me adjust that thickness. So now I have another line that goes through that corner, the center, and then the other corner of the rectangle. So it goes through here, the center, and here. Okay, so don't forget that we have decided that this was the kind of parabola that opens to the right and to the left. So it will have a point right on the edge of the rectangle here and here. But then it goes up close to that asymptote, and it goes down close to that asymptote, but doesn't intersect it. Then this one here will go up to that asymptote and doesn't intersect it, and then it goes down close to that asymptote and doesn't intersect it. So we use the 25 and the 4, we use it to draw the rectangle. Then we draw the oblique asymptotes or slanted asymptotes, and then we decide if it opens right or left. So when I look at this next one here, I see y squared over 25. So it's a hyperbola that is centered at 0, but it actually opens up and down. I will use the 25. That's a b squared equals 25. So that leads to b equals positive and negative 5. And then I have a squared equals 4. That will be a equals positive and negative 2. But what's important is the b squared is the one underneath the y. So this will mean 5 units down and 5 units up. And the 4 was the number underneath the x squared. So the plus or minus 2 will be points to the right and to the left. So we draw the rectangle using that, and I'm going to go to the next page. And the rectangle is going to, or maybe it was here, sorry. So I go 2 units to the right from the center, and 2 units to the left, 5 units up, this is the center, 5 units up, and 5 units down. Then I draw my rectangle. And let me go ahead and get blue. And I just draw the boundaries of the rectangle. So that's just the boundaries for the rectangle. Now we draw the asymptotes. But I'm going to make that a little bit narrower. So we have an asymptote that goes through this corner, through the center, and through the opposite corner. And I'm quite a bit off there. So let me go ahead and adjust that. Okay, now I do the same thing. And I go through this corner, through the center, and through the opposite corner. That's a little bit better. Okay, so now the difference is, don't forget that you're starting with y squared over 25, so it opens up and down. So where does it start? It will start right on the box, and then it go up close to the asymptote, up to close to the other asymptote, but doesn't intersect it. Then it will come here and go down close to the asymptote, and then it will go down close to the asymptote. And now we have the graph of the hyperbola. Okay, I want to give you another example. Even though we'll have more conic sections here, I want to give you another example of graphing hyperbolas. So let me open a new page here, and let's say that you're asked to graph y squared over 4 minus x squared over 9 equals 1. Okay, so the first thing you should notice is that I have a y squared over 4, so I know that this is the kind of hyperbola that opens up and down. The next thing, oh, and it is a hyperbola because you have a minus in between. Right now we're only looking at hyperbolas anyway. Now, next, you want to know what your boundaries are going to be for that graph. So the 4 that you see right here, and I don't care whether you call it b squared or a squared, but that will give you a b squared equals 4. So that's going to give you b equals positive and negative 2. Now, in that, since it is underneath the y square, it means 2 units down and 2 units up. Now we have a squared equals 9, and that gives me a equals positive and negative 3. That means 3 units to the right and 3 units to the left from the graph. So we go ahead and let me go ahead and draw my y-axis, my x-axis, and then I'm going to make sure that I have 3 units on the right and 3 units on the left, at least 2 units up and 2 units down. And then I'm going to draw my rectangle. I would have my points here, 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 and here for the corners of the rectangle. So let's go ahead and draw the rectangle. I think I'm a little bit off on that one, but I'm going to leave it alone. I just wanted to give you another example. And then here. Okay, so now we draw our oblique or slanted asymptotes. So let me get another line here, but make it a little bit narrower. So I have an asymptote that goes through this corner, the center, and the opposite corner. Then I have another one that goes here to this, through this corner, the center, and the other one. And don't forget that from the very beginning, I decided that it was the kind of hyperbola that opens up and down. So where will the graph be? It has to touch the rectangle here and here. But then it goes up from that, close to the asymptote, up from that, close to the asymptote, down here, close to the asymptote, down here, close to the asymptote, and you have a graph. Okay, so the next part of this section will actually have examples of parabolas, circles, and ellipses, and you'll have to identify them all together. But what I want you to do while I'm gone is make sure you finish section 13.1 and that you are comfortable with the graphing of the circles and the ellipses. I want you to do in 13.2 the questions that have to do with graphing the hyperbolas, like the ones we have been doing here, like this ones. And then when it gets to the point where it says identify various conic sections, we will do those when I get back. Also, don't forget that your 13.1 online and written will be due on Monday when I get back. But after I answer questions in class on Monday, you have the written homework and then the online that night. So, they're both open, the 13.1 and the 13.2, so that you can work on those already while I'm gone.